Hi, this is a video to talk about some stuff I've been doing for the texture cluster module in MicroSplat. Um, so this week Unity posted up some code, which was very nice of them. Basically, a while back there was this paper by Eric Heitz, and basically the idea of this paper is, hey, tiling textures are a problem. Here's a technique to solve them, and it does a pretty good job of explaining the technique. Basically, what it does is for every pixel, it kind of makes three virtual triangles somewhere and then blends them together. This is very similar to how texture clustering works in MegaSplat. It's kind of similar to how the MegaSplat technique actually works when it's on a Unity terrain. Um, and So a while back, I'd played with this a little bit and didn't get a good result. I probably had some bugs in my code or something, just didn't implement something correctly. But basically, the tricky part of this paper is the way things get blended. And so you can see it right in the title. It's basically high performance by example noise using a histogram preserving blending operator. So that is the key of what makes this technique particularly complex. And luckily, Unity Labs basically implemented a version of this into the standard shader. And I spent some time this weekend really looking at this. And my original analysis of this was like, hey, it works, pretty well on things that kind of already tile well, really high detail kind of noise, but that it didn't work well on rocks and the things that we're doing with terrain. I must have had something wrong in my implementation because theirs seemed to work a lot better than mine did. So I took a look at that this weekend and tried to implement it into MicroSplat. And there's a number of things that they haven't implemented yet in their version, things like support for alpha channels, stuff like that, that made it not really great for MicroSplat. But while I was doing this, I started thinking about what this is really trying to solve and how it's really trying to solve it. And somewhere in my brain, that similarity with MegaSplat maybe had something to do with it. But what I realized was that effectively there was another way to do this paper that was much simpler. And that was to remove this histogram preserving blending operator part of it, because this is what requires pre-processing the textures into another format and requires generating lookup tables and a whole bunch of other stuff. You even have to do things differently for texture compression versus non-texture compression. So this is a bunch of math, a bunch of source code, a bunch of complexity to deal with, and it sort of came to me that I could just replace this histogram preserving blending operator with the blending we already do all over the place in MicroSplat, which is height-based blending, because this just works on any texture, but I know I have a height information. And actually, if you were trying to do this for another shader, you could generate something that would work well enough by taking the luminosity of the image or something like that, and it would probably work pretty well too. So I posted a bunch of stuff on the forums about this if you really want to get a deep dive into it. But I wanted to show it off because I think it works pretty well, and the workflow of it is very easy. So here I have a terrain here, and right now texture cluster mode is turned off. So it's basically just tiling this texture. And you can see how this texture, you can see this repeating rock, kind of repeating along here. It still looks pretty good, even though it's a pretty tiley texture, just because it's a great texture and because we're breaking it up with the terrain. But the more area this covers, the more you're going to notice it tiles. So first I'm going to switch on traditional texture clustering. And in MicroSplat, this comes in two variations, two versions, 2 variation and 3 variation mode. 3 variation mode says basically give me 3 copies of every texture, make them slightly different, and then I'll blend them up with a noise function and create some variation. And you'll notice that immediately takes out all the tiling. And the nice thing about this is that you get all this nice variation because you're actually blending 3 textures. So this texture over here is very different than this texture over here. And so we get some really nice variation across the surface. The downside of this is that, well, you have 3 times as much texture data, which you then have to author. And so that's a lot more memory going through the pipeline. It's a lot more data to manage. And, with tools like Substance and things, it's not so hard to generate these textures, but if you're not making your textures in Substance and you don't have an easy way to produce variations on a theme, then it can be pretty hard. So while I think this is a more advanced technique and better quality, the idea of having a technique that just worked on the textures you had is very appealing to me. So now I'm going to switch it over to the stochastic method. This is not the method done in the paper. This is a modification of this method. And what it does is, rather than using the histogram preserving operator, it just uses a height map blend. And what you'll see is that you get some pretty good results. We no longer have those extra texture arrays, all that extra texture memory. We're just using one texture. But by blending these things together, we're getting a lot of variation over the surface. You can't really see it tile anymore. It does have a self-similarity about it, but it doesn't actually tile. And that's a big win, because self-similarity is okay. We want, grass to look like grass everywhere, and rocks to look like rocks, but we don't want to see tiling. And so this actually does do a good job of eliminating this without having to produce all these extra textures from the artist. So I'm pretty excited about that, because usability is very important. If I can just click a button on and get better usability, better results, that's pretty exciting. If I have to do a bunch of work for it, it's cool too, but not as exciting as just clicking a button and having things look better. So yeah, all you have to do, you don't have to make any extra textures or anything. You just switch this mode to the stochastic mode, and it will perform the new technique. And in terms of cost, this basically requires sampling each texture 3 times. So it's similar to triplanar. And it's similar to the actual original TextureCluster 3, and that you had to sample 3 textures. In this case, you're sampling the same texture 3 times, which can potentially reduce the memory bandwidth a bit, because you're not dragging 3 different textures through there. You're just dealing with one. So yeah, so I'm pretty excited about that. Now, some downsides of it is you'll notice that it definitely increases the frequency of rocks. If I compare this to none, which is our so you'll see that these rocks, they sort of have this reasonable spacing. There's a lot of this low-lying area where the sort of wetness is, right, in this. And because I'm using a height-based operator to blend these, instead of this histogram preserving one, or some other operator, it does tend to kill a lot of these lowland areas. I have some ideas that might be able to remove that by basically biasing it a bit to help preserve the lowland areas. But I kind of wanted to release this to let people play with it right away and get some feedback on it. But yeah, you'll see you still get them. There's still this lowland area here if I'm not clipping through it. But you don't get them as much. You get more the rocks, because they're going to dominate in a height blend. So yeah, when I checked this actually against the histogram preserving one, I actually found that it wasn't that much different. It tended to still make the number of rocks seem higher. It tended to still squash the lowlands somewhat. Maybe not as much as this one does, but similar. So I'm pretty happy with the result of this. It requires very little complexity on the code side, which is a nice win. It didn't, the original paper required all this pre-processing of the textures. It actually took, to do a reasonable size texture array, it took a good 5 to 7 minutes to process the textures into the format that it needed, and it would produce all these extra textures that you needed for some lookup tables. And so all that goes away, and we get a result that's very similar to the paper, without having to do all that extra pre-processing and work. And it works with every compression format. The paper only supplied code that worked with DXT compression or non-compressed textures. So if you got onto Android or something like that, that would be problematic. And this just works with everything, with all the other MicroSplat features. And so yeah, I'm pretty happy with that. Great, that's it for now.